Hey there, A2Trig folks. Happy remote learning. In this video, we're going to be talking about the day 3 lesson, which is shape, center, and spread of data. Before we get too far into this, please know that there is a vocab sheet that I've uploaded to Google Classroom and onto our little um, remote learning schedule calendar thing. So please don't feel the need to write down everything that you see on the following pages because you will have that available to you. If it helps you to write things down and paraphrase it on your own, by all means, go for it. And you know the drill. If you need to pause the video at any point, please do that. All right, so let's get into some math, shall we? So when we're talking about patterns in stats, what we're typically trying to figure out is how was our data centered, meaning what was the mean or the median? How was the spread, meaning was the data fairly centralized or was it all over the place? AKA, kind of think of this like the range from a previous lesson. And what was the shape? The shape could be either symmetric or skewed. So is it pretty evenly distributed, or were maybe certain values pulling the average higher or lower than what it should have been? And then lastly, we have unusual features. So those are like outliers or were there gaps in the data, things along those lines. And we'll see some examples. All right, next are two terms that we have: quantitative versus qualitative. So attributes should only be used to describe quantitative data, so numerical data. And that's because we are actually running calculations on these, right? So if I want to do quantitative data, I could say, how many siblings do you have? If I asked everybody that, you would answer with a number. I have 0 siblings. I have 2 siblings. I have 1. And then I could go through and say, okay, the median here would be 2 siblings with an average of 2.5 or something along those lines. We should not be using these to describe qualitative data. So qualitative is kind of a quality that something has. So I could say, what is your favorite color? In which you would answer red or blue or purple or mauve. There's really no way for me to run calculations on that. I can't say that everyone's favorite color on average is a yellow point red or an orange point 4. That wouldn't really make sense. So quantitative data deals with numbers or quantities of things. Qualitative deals with qualities. Now, when we get into graphing these, we're going to be using histograms. A lot of people think a histogram and a bar graph is the exact same thing. It is not. There are minor differences. So a histogram only deals with number ranges, not categorical data. So not qualitative, it is only quantitative. Because of that, there will never be gaps between our bars unless a bar has a height of 0. That is the only time that these two different bars would not be touching. The reason for that is since we're dealing with a number range, numbers kind of operate in a continuous pattern, right? So where one range leaves off, the next one starts up. All right, so first let's talk about center. So the center of a graph is typically going to be the median, is what we want to use. But sometimes it will be more accurate for us to use the mean or the average. So mean and median typically tell us what the center of our data is. So think of this like a quiz or test. If we were to say, what was the class average? I say it's an 83. That gives you guys a pretty good idea of how the class did. However, if I had some values that maybe skewed it, maybe 5 people were absent that day and their grades are zeros, and the class average now because of that is a 73, well, that's maybe not as accurate. So when we're talking about the center of a distribution, we're going to use the median. And that's going to be smack dab in the middle on our display. Again, we'll see some examples as we go through. Next, when we talk about spread, spread tells us how far apart our data is. So how variable is it? If it's over a wide range of data, there's said to be a large spread. If it's pretty narrow, pretty condensed, we say it is a smaller spread or there is less spread to that data. Typically, if something looks like this with our data, that means all of the values typically are closer to the mean and median, whereas over here, everyone's kind of all over the place. All right, so now we've got a big vocab sheet. Again, this was PDF'd and shared with you, so do not feel the need to write this down. When we get into shape, a graph is said to be symmetric if there's some symmetry about it. So if the left side looks the same as the right, if I were to draw a line straight down the middle where the median would be, does left look the same as the right? Sure does. So that would be a symmetric graph. Next, we get into number of peaks. Well, peaks are the highest point, so right there, that would be a peak. And a peak represents a mode because that's the most common result. So when we're talking about peaks here, there's either going to be one, two, or many. And since it's a mode, if there's only one, it would be unimodal. If there's two, it'd be bimodal. And if there's more than two, we'd call it multimodal. Typically in this class, we are going to prefer to see unimodal distributions. Those are the most easily interpreted. Next up is skewness. Skewness is where some people tend to get things backwards. Skewness is when you have some values in your data that might unfairly skew the data. So the example I gave earlier in this video is if I gave a test, but several people missed the test and they had zeros in, those zeros would skew the data downward. Or if I go to, let's say I go to Oswego and survey everybody for how much money they make, and I get the town average, but then Bill Gates moves to town. Well, he's going to skew the average pretty significantly there. The way we can visually determine if something is skewed is whichever way the tail of the graph kind of tails off and levels off, whatever direction that goes, that is the direction of the skew. So the direction of the tail is the direction of the skew. Now, if something is not skewed, nor is it symmetric, then that would mean all of the bars in the histogram would have to be roughly the same height, give or take. We would call that a uniform distribution. All right, onward we go. Gaps in a graph. That means we have little bar heights of 0. So these are the unusual features we kind of prefaced earlier. So if you see two separate clusters of data, that means there's a gap in between. And then an outlier, we kind of discussed this in a previous, I don't know why I'm scratching that out. That's supposed to be an underline. There we go. An outlier is one or two or maybe three data points that really don't fit the norm for all the others. Now, when we talk about skewness and mean, what this means, what the mean means, is if we're skewed right, okay, so if I follow the tail of this graph, this first one here, skewed right, that means my mean, the average, is to the right of my median. Because remember, the median is always going to be in the middle, so the middle value. So the mean is bigger than the median, so the mean is to the right. If it's skewed left, meaning this thing kind of tails downwards, that means the mean, the average, is to the left of the median. So this would be skewed left. The mean is smaller, less than the median. And I made up an example here. Let's take a look at this data set. I put them in order for you. You're welcome. The median here would be 5. And if I wanted to find the mean, well, I would just add those up and divide it by 5. So not too terrible. But let's play a little what if here. What if instead of 8, I change that to 800? My median is not going to change at all. That's still the middle number. But my mean, my average, if this was an 800 instead, that's going to be monumentally larger. Same logic, if I said instead of 2, that was a 0.2, that's going to drop our average, okay? So if you have an abnormally large or small number that messes with the average, you are going to have some sort of a skew. All right, on this next one, we're just going to look at a graph and figure out skew left, skew right, or uniform. So I'm going to go through and just kind of click and delete each one. If you want to pause the video as we're going through so you can kind of guess ahead, that's not a bad idea. All right, first one, the tail goes to the right, so that'd be skewed right. Second one, our tail goes to the left, so it's skewed left. Third one, left and right side look pretty much the same, so I'd call that symmetric. Next one, the tail is going to the right, so we are skewed right. Next one here, our tail looks like it's going to the left. Lo and behold, skewed left. And this one would be uniform because they're all roughly the same height, give or take. All right, this will be our final example where we just kind of look at things and interpret them. And then we'll go through and we'll see a very verbose explanation that Miss These Two gave a few years back that was just so great I didn't see any need to retype it. Here we have two separate histograms. One was when people were getting asked as high school seniors, what age would they like to get married? So picture you guys in a year or two answering the question, when do you want to get married? Looks like not a whole lot of people wanted to get married right out of the gate. And most of them wanted to wait until their late 20s, maybe early mid 30s. They thought that would be a good time. Then they interviewed a group of senior citizens, not seniors in high school, senior citizens. And they said, what age did you actually get married? So this group over here, they're kind of projecting when they want to have this happen. This group, they're saying, when did it actually happen for us? So question one says, compare the shapes of the graphs and what conclusions can you make about it? I'm going to scroll down here to have Miss Thiestu's explanation. If you guys want to pause it, that's not a bad move. So it says the high school students is pretty close to symmetrical. So there's, just as many of them who are predicting an older age as a younger age. The seniors, again, the old folks, seniors, is certainly skewed to the right. So a lot of them got married in that 18 to 21 age range. And then it kind of tapered off as they got older. Part B, compare the spread of each histogram. What conclusions can you make from the spread? Remember, the spread is how far apart is the lowest to the highest values. Think of this like the range. Was it pretty condensed or are they pretty spread out? Pretty condensed or pretty spread out? Well, here, says many of the seniors, again, older folks, seniors, were close to the same age when they got married. So if I look up here, this seems to be oh boy, that's not what I wanted to happen. This, God bless America. Okay, I can't figure out how to get that to stay put. Right here is where most of the responses happened. So it's pretty condensed, whereas the high school students was pretty all over the place. The overall spread, however, for the older folks was bigger because they have an additional age range of 14 to 17. And that indicates that maybe some of them got married much, much younger. So this little age range right here, that does not even exist on this graph over here. So there are, let's see, I'd call that maybe 5 responses in there. So that would mean essentially people your age getting married at the age of 14 to 17. All right, and then the last bit we're not going to cover in this video. I'm going to link them to the classroom page in the Google Doc. I have a few different videos here. If you guys want to kind of go through and take a look at some of these, if certain pieces aren't making sense to you, by all means, feel free to do so, and this will go through and further explain those. But you know the drill. If at any point something does not make sense, please, 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 please send me an email, ask for help. Good luck, have fun, be safe, roll tide.